Hello everyone, welcome to the next unit lecture in which we will be studying about Introduction to Functions. We will be discussing about functions and its type in this lecture. So let's get started. Functions in C++. A function is a self-contained block of code that performs a specific task. So when we define a function, it has a block of code which we can use again and again in many in the same code in or in the different code to perform a specific task. It makes code modular, reusable, and easy to debug. So if something is not giving a correct answer, so first we will be checking the function block. Is it giving the correct output or not? So in C++, supports both predefined library functions and user-defined functions. Um, so predefined library functions are other functions which come with the language, and user-defined functions are the functions which are defined by the user or the programmer. Function reduce redundancy by enabling code reuse. So we can use the code again and again so that the code has less redundancy. So now we'll be talking about types of functions, among which first is library functions. Built-in functions provided by C++ standard libraries. So in the C++ language, we come with some standard libraries which have some functions which we can use in our uh, codes. So like examples like sqrt for calculating a square root, power pow is for calculating a power of number. strlen is for length of a string, abs for absolute, and so on. Declared in the header files. So if we want to use the library functions, we need to use the library files for it. So like math is for sqrt string is for string functions like strlen. iostream is the common function which input output stream which we use in our every code. Saves times and effort, just call and no need to define. So we just need to call them. We need to import the header file and just we can use the function. We does not need to define the code inside because code is already written. Second is user defined functions created by the programmer to perform custom tasks. So when we don't have any functions, the any library function which we can use to perform our tasks, we can define our own functions which can be used to perform a custom task to perform some work which we are assigning to it. Can be written once and used multiple times. So it also be written once and can be used multiple times in the same code, or we can inherit this it into another files also. So structure will be like we will declare the function, then we will write the definition, and then we will call the function. Improves clarity, flexibility, and maintenance of the program. So it also works same as the library functions after we have declared and defined it. So we can call it anywhere in the code. So it improves the clarity. So we don't need to write the code again and again and again. So improve the clarity, flexibility, and maintenance of the program. Next is we will see recursive functions. One of the important topics are recursive functions, a function that calls itself within its own body. So we will see an example about it soon. So useful for the problems with repetitive substructures. Example factorial is Fibonacci. So factorial of a number, if we want to calculate a factorial of a number, we need to generate the Fibonacci series. Then it is a very useful term. The recursive functions must have a base case to stop recursion. So uh, to stop recursion, like yeah, it's calling again and again itself. So it must have a case where it has to stop. Otherwise, it will be an indefinite recursion. So can be memory intensive if not optimized. So if we don't have a base case, or we are not using it properly, so it can be a heavy load on the memory, because if we have many recursive functions running in background, so it can not be good for our memory. So this is an example of factorial of a number. So we can see int factorial, int n. So yeah, this is the definition. So declaration, then we are writing the definition. If n equal to 1, return 1, else return n star n multiply factorial n minus 1. So this will run until and unless we don't not get this condition true. So if we have 5, then it is not equal to 1, then it will do 5 into n minus 1. So it will call this, then 4, then 5 into 4 into 3 2 1 like that, and at last when we'll receive 1, it will return 1, so it will return the factorial at last. So last topic in this unit is, in this topic is inline functions. So replaces the function call with actual function code at compile time. So when we call the function, so it replaces the actual function code at compile time, reduces function call overhead, improving performance for small functions. So if we have a small function, we have write a small function, we are calling it again many places, but it does not require to use it to again and again, write again and again. So declared using inline keyword. So we have one more keyword and here, that is inline, which is used to call this function. Best for short and frequently used functions. So if we have a small function like sum, which is doing sum of two numbers, we are taking just an example. So if we have a function sum there that is summing two numbers, so instead of doing a plus b again and again in the whole code, we can just call sum, and we can declare this as inline, and it will replace the function with the actual code on the compile time. Thank you.